In this short screencast, we introduce the concept of sampling distribution of the mean. So consider a website, buystuff.com, where the mean order size is mu equal $200 and the standard deviation is $30. What's the probability that the mean of a sample of 25 orders is less than $212? Not just one order, a sample mean of 25 orders. Assuming, before we talk about this mean of 25 orders though, assume a normal distribution. What about the probability that one randomly chosen order is less than $212? Well, we know how to do that. We just find the z-score, 212 minus 200 over 30, which is 0.4. Use norm mass dist, and we get that 66% of individual orders are for less than 212. That's not our question. Our real question is, what's the probability about the mean of a sample of 25 orders? What's the probability that that is less than $212? Well, we saw that with proportions, if a population proportion is p, then the collection of all sample proportions was a normal distribution with mean p and standard deviation square root of p 1 minus p over n. There's variation in the sample proportions, but we can control that variation because we know what its standard deviation is. Something similar is true for sample means. If a population has mean mu and standard deviation sigma, then if you look at the sample means, x bar, the collection of all sample means, has itself mean mu, has standard deviation sigma divided by the square root of n, and, bonus, is approximately normal even if the original population is not. As always, n is the sample size, and also the larger n is, the closer an approximation to the normal the sample means are. So at BuyStuff, the mean order size was mu, and the standard deviation is $30. So when you look at the sample means of size n equal 25, they're going to follow a normal distribution with mean 200 and standard deviation 30 divided by the square root of 25. So we find the z-score for the mean of a sample of 25 orders, 212 minus 200 divided by the whole 30 divided by the square root of 25. And you get 2. Norm mass dist of 2 is 0.98, so the probability that the mean of a sample is less than 212 is 98%. Remember, for an individual order, it was only 66%. So while an individual order might be less than 212, it would be with only probability 2/3 or 66%, a sample of 25 orders almost certainly has a mean of less than 212. So if a distribution, even if a distribution is skewed, the sample mean will be normal, or normal-ish. Depends on the sample size n. But for any largish n, like 25 or more, it'll be very close to normal distribution, even if the original data is skewed. And even if a distribution has a lot of variation, a large standard deviation, the sample means will have a small or a smaller standard deviation because you divide by the square root of the sample size. And by using sample means, we'll be able to estimate the population mean well with confidence intervals, and by using the sample means, we'll be able to test hypotheses, as we'll see in coming lectures. Okay, your turn. At BuyStuff, what is the probability that a single order is for more than $206? What's the probability that the mean of 100 orders is for more than $206? The answers are on the next slide, so why don't you pause the video and try it before you look. Okay, here's the answers, and we're done.